so much. Let's hit record. Okay. So, all right. So guys, what we're doing here is we're going to talk about graphs of other trig functions. So what we're going to be doing today is we're going to be graphing secant, cosecant, and tangent and cotangent. Okay. If y'all remember, there was some reciprocal identities. So we said that the sine and the cosecant were reciprocals. So it tells us right here in the middle that y equals cosecant of x is the same thing as 1 over the sine of x, right? And right now we were talking about, hey, like, what's the sine value over here? What's the y value here? Oh, it's 0. What's the y value here? Oh, it's 1, 0, negative 1 back to 0, right? So the one thing in math that we can't ever do, guys, we can't divide by 0. Okay, that's just the one thing we don't want to do. And so what happens when we have those sine values? So I want you to look here at the picture, and I think my pencil is working much better today. I changed the battery. And I'll tell you what, let's do this. You can kind of see they have this. This is my sine function, right? So right here is when the sine value is equal to 0. So when the sine value is equal to 0, that means that the cosecant is going to be undefined because we can't divide by 0. And when we do that, what we get are these things here, and these things here are called vertical asymptotes, okay? What vertical asymptotes are, they're vertical lines that are kind of like boundaries. What happens is the graph gets really, really close to those vertical lines, but it never actually touches them. It just gets closer and closer and closer to them. So, I'm sorry, what's your name again? Yeah, Javier. So, like, if I said, let's just make this up. The distance from where I'm standing and Javier is sitting, let's say it's 30 feet. And suppose I said, I'm going to go half the distance between myself and Javier. Where would I be now? How much feet would I be closer? I'd be now at what, 15? And then I would say, okay, let me go half again. Then I would be at 7.5. And we can keep playing that game, and I'm going to be cutting the distance between myself and Javier in half. But you know what? As close as I'm going to get to Javier, I would never actually get to Javier because I'm only going, what, half the distance, right? So I keep getting closer and closer and closer. That's the idea behind vertical asymptotes. The graph is really, really close to those lines, but it never actually touches them, okay? All right. And so it says here, if sine of x is equal to 0, then 1 over sine of x, which is our cosecant, is going to be undefined, and the graph has a vertical asymptote. That's what we're talking about, those lines. And it tells me here that this is going to occur, oh, come on, I jinxed my pen. This is going to occur when x is a multiple of pi. Anytime we have a multiple of pi, we're going to have one of these vertical asymptotes, okay? So pi, 2 pi, 3 pi, 4 pi, 5 pi, or 0, negative 1 pi, negative 2 pi, negative 3 pi, so on and so forth, okay? Now, we're going to do the same thing for the secant graph. So the secant graph is the same thing as 1 over the cosecant, right? And again, we're going to have these kind of vertical asymptotes. And the way we're going to figure out where they're going to be is if you look at this, here we go, this part right here, we can say, look, when is the cosine equal to 0? When we are at odd multiples of pi over 2, like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, things like that, that's going to give me those vertical asymptotes for the secant function, okay? Because that's when the cosine is going to be equal to 0. And since the secant is 1 over cosine, those vertical asymptotes will appear there as well, okay? So what I'm going to do here, y'all, is I'm going to show you guys, we'll kind of skip over some of this business. I'm going to show you guys how do I graph these functions? How would I sketch a graph, okay? So anytime I'm going to graph a secant or cosecant, I want to graph what is the reciprocal graph first. So if you notice here, the first part says, let's graph y equals negative 2 cosecant of 3x. The first thing we're going to do, we're going to graph we're going to graph this one over here. There we go. We're going to graph y equals -2 sine 3x. So let's do that. Okay, so guys, for this graph right here, anybody know what's the amplitude? 2, right? Because we're going to take the absolute value of -2, which is 2. Then we need to find the period. So remember what we're going to do. We're going to take 2 pi, and we're going to divide it by 3, right? Okay. Second thing we're going to do, we're going to solve this inequality. Okay. So remember, right now, guys, what we're doing, we're finding the first point, we're finding the last point, right? So we're going to divide everything by 3. So that's going to give me 0 is less than x, which is less than 2 pi over 3, right? Okay. Now remember, we found point 1, we found point 5. We still need to find points 2, 3, and 4, right? Okay. So let's do this over here on the side and let's see what we come up with. So what do we have? 3x? Okay. So remember what we're going to do. We're going to set 3x is equal to, what's normally our second value? Pi over 2. Excellent. And then we're going to set 3x equal to pi. And then we're going to do this one more time. 3x equals, perfect. You guys got this. Okay. Guys, just like we did on Wednesday, if I have that 3 in front, I want to get rid of that 3 by multiplying by the reciprocal, right? 1/3. So those 3's will cancel. There's be a 3 right there. And everybody agree this is going to give me pi over, there you go. Okay. 1/3 again. 1/3 again. Pi over 3. Okay. One more time. 1/3. 1/3. And this 3 and that 3 will cancel, and that should give me a pi over 2. Okay. All right. So guys, just like we did last week, right? Just like we did on Wednesday, I'm going to make a little table, right? So the first value we have is 0. Second one we have is pi over 6. The next one is pi over 3. The next one is pi over 2. And we said the last one was 2 pi over 3. Okay. And then now we're taking the sign, and the next thing we have is 3x, right? So 3x was 0, pi over 2, pi, 3/2 pi, and 2 pi. And then now we're going to take the sign of those values, the sign of 3x. Okay. So what do we say the sign of 0 was? Anybody know? 1. Sign of pi over 2? Hold on. So let's go back again. Let's come back one more time. Sign of 0. What's my y value over here, guys? What's the y value over here? 0, right? Okay. What's the sign of pi over 2? 1. Sign over here? 0. The next one? -1. And then finally, 0 again, right? And then now, what do we have in front of it? We have a -2, right? Okay. All right. So now we're just going to take each of those numbers and multiply them by -2. So everybody agree this is 0, -2, 0, +2, and 0, right? Okay. So now that we've done that, we're going to go ahead and sketch the graph. Look at our x values. 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. So if I zoom in, those are those those are those values that are there, right? I know it's a little hard to see. Pi over 6, pi over 3, pi over 2, 2 pi over 3, right? Okay, so let's graph the sign, the one that we have. So it's 0, -2, 0, 2, and 0. So 0, I'm gonna do this in blue. So 0, -2, 0, +2, and 0. Okay, this is all we need for this part, guys. We're gonna go like that. Okay. Now remember what we said. Anytime that we have these x-intercepts right here, where my values happen to be 0, those are going to be our vertical asymptotes. So what I'm going to do, I'm going to do a little dotted line like this. And I'm going to do another little dotted line like this. And I'm going to do another little dotted line like that. Okay. Since the cosecant is 1 over the sine, what my graph is going to look like now, this value will still be the same point. And since we have these vertical asymptotes, the graph's going to get really, really close to those lines, but it's not going to touch it. And there's the cosecant graph. So what am I really doing? As long as I know how to graph the sine, can I do the cosecant? It's just going to be those little kind of curves, right? So the only thing that we've added, y'all, from Wednesday to today is where we have those x-intercepts, put those vertical asymptotes, and then you can do your graph over there. Does that make sense? Right? And guys, we could continue this, right? You could say, well, okay, well, what is it going to look like over here? It's going to kind of do that, right? And then my vertical asymptote, there would be another one right here, and there would be another one right here. And then we could continue our graph. Say, look, there's got to be a point there. There's got to be a point there. Because it's periodic means it repeats itself, right? It just kind of keeps doing the same thing over and over and over again. Questions so far? Are we good? Yeah. So, yeah, because it's just 1 over that number, right? You know what I mean? It's just 1 over that. So that'll be that same value. Okay. I'm sorry, go ahead. Undefined means you can't, there's no calculation for it. So if you think about, right. So undefined, so think about it this way, and I'll tell you, we don't even need to calculate for this. Let's scooch over here. Okay, so let me ask you a simple question. What's 24 divided by 3? Okay, now I'm going to ask you the hardest part. Why is it 8? Anybody know? Let's do the multiplication. Why is it 8? Because, but don't make it that hard. Think about what's the multiplication. What would be the multiplication reason you would give me that 24 divided by 3 is 8? You would say because this times this is going to give me that. What would you say? If I wanted to get 24, what do I have to do with the numbers 3 and 8? Multiply, right? You say why? Well, because 3 times 8 is 24, right? Okay, so let me ask you another one. What is 36 divided by 9? 4. Okay, same reason, right? Why? Well, 9 times 4 is 36, right? Okay. What is 0 divided by 7? 0. Okay, you already know what I'm going to say, right? Why? Because 7 times 0 is 0. Okay, now let's do it this way. What's 5 divided by 0? Undefined. I'm going to ask the same question. Why? Because 0 times whatever number you put here is never going to give you what? Never going to give you 5, right? It's never going to work. Can't put anything, you can't put anything there that'll work, right? You can't put 7, it won't work. You can't put 5, it won't work. You can't put anything, it's never going to work, right? So that's what we say it's undefined. You cannot do it. And what happens mathematically, y'all, if you start doing this, let me turn this on. So if I say 7 divided by, let's take a number close to 0, like 0.1, which is 1/10. Look what happens, 7. Okay. 7 divided by 0.01, 700. So do you see what's happening? What's happening to our number, to our final answer? It's increasing by a power of 10. More important, but the idea is that's because I'm dividing by a tenth or a hundredth or 1,000. But the idea is the number is getting what? It's getting bigger. So that's why we have those values. You have the way the graph is looking. At points it does this. Why? It's getting bigger and bigger and bigger, or it's getting smaller and smaller and smaller, right? That's why it's going down in that negative direction. That's exactly right. Like I said before, when I was getting close to Javier, but I'm never going to actually reach him. We're getting infinitely close, but we never actually get there. Right? Good deal, good deal. All right. Okay. So, guys, we're going to do the same thing here. We're going to graph the variation of secant of x. So the graph we want to do is we want to graph y equals 3 secant of 2x. How are we going to do that? We're first going to graph y equals 3 cosine of 2x. Okay. So first thing we're going to do is we're going to sketch this graph. So let's first find the amplitude. Okay. Anybody know what the amplitude of this graph is? 3. Okay. Then we're going to find what we call the period. So the period is going to be 2 pi divided by what number here? 2. Good. So 2 pi divided by 2 is just pi. Okay. Now we're going to go ahead and solve this inequality. 0 is less than or equal to 2x, which is less than or equal to 2 pi. So we can divide everything by 2. So 0 is less than or equal to x, which is less than or equal to pi. Okay, so remember, we have found our first point, and we found our fifth point. And now what we're going to do is we're going to set 2x equal to pi over 2. 2x is equal to pi. And one more, 2x is equal to, there you go, you got it, perfect. So we can find our second, third, and fourth points, right? All right. Anybody know what I should multiply to get rid of that 2x? Reciprocal, right? 1/2. 1/2. 1/2. And I'm just going to do the same thing here, y'all. So these 2's are all going to cancel. And this is going to give me x equals pi over 2 times 1/2. Pi over 4, perfect. Oops, put a pi both of them in there. Oops. Okay. This one here should be pi over 2. And then the last one, 3 pi over 2 times 1/2. 3 pi over 4, right? So Tomas, this is what you're referring to earlier, right? Coming up with these values. Are these a little bit easier to do? It's maybe when you have that minus pi or you got to add or subtract something. Yeah, it can get a little tough. All right, so guys, now let's go ahead and make our chart. So we have 0, we have pi over 4, we have pi over 2, we have 3 pi over 4, and we have pi. Okay. And since we have a 2x, I'm going to put a 2x here. This is going to be 0. These will be our standard values. And then we're taking the cosine of this. All right. Okay, so let's see if we remember. Anybody remember the cosine of 0? 1. Excellent. Cosine of pi over 2? 0. Cosine of pi? -1. Excellent. Cosine of 3 pi over 2? 0. And cosine of 2 pi? Perfect. All right. And then what number did we have in front of it? A 3. So we're going to say, what's 3 times cosine of 2x? So remember, y'all, all we're going to do now is take those numbers and multiply them all by 3. So 1 times 3, 0 times 3, negative 1 times 3, 0 times 3, and 1 times 3. There we go. Okay. So what I want to do now is I'm going to make a chart. It's going to look like this. Here's my x. Here's my y. My x values go from 0 to pi over 4, pi over 2, 3 pi over 4, and pi. My y values are going to vary between 3 and negative 3. So I'm going to go like this: 1, 2, 3, 1, 2, 3. And then all we're going to do is just connect our dots. So at 0, we're at 3. And I'm going to do this one here, guys, in black. At pi over 4, we're at 0. We're at minus 3. We're at 0. We're at 3, right? And so here is our cosine graph, right? Just like we did before. I'm going to put my vertical asymptote. My vertical asymptotes, y'all, are going to be right here. I'll make that a little bit thicker. There we go. Okay. And I'll come back in green, and now we can go ahead and graph our secant function. So remember, this point here is going to be the same one, right? One value right there. My graph's going to look like this. This point here will be the same one. Remember, it's going to go like that. Be the same one, and go like that. Here's my secant graph, right? So my whole point here, guys, is if you know how to do one, boom, you can do the other, right? So look, before I go on to anything new, first thing I want to do here is I'm going to come back to our Blackboard page. Okay. And I told you guys that today we're doing 4-6, and Wednesday we're going to do 4-7. We'll do 4-7 on Wednesday. But you do have a written class assignment, guys. So let me kind of go over this part right here just real quick so that you kind of understand what it is. So class assignment 1 is due by next week. Okay, you can turn it in by the end of class. If you're going to be out next Monday, guys, just send it to me through Blackboard messages, okay? And here's class 1. You guys can work together on it, okay? So because we're in the middle of this pandemic, and you may feel comfortable walking right up to somebody, and you may not. Please don't walk up right next to somebody unless they've said it's okay for you to. But you guys can work together, okay? So in some of my online college opera classes, what they've done is they've set up like a WhatsApp type group, and everybody exchange phone numbers. If you guys want to do that, that's fine with me. It's up to you guys. But I want to show you what class assignment 1 looks like. So let me click on this right here so that we can look at class assignment number 1. So look at the first question. Let's graph the following function: y equals 2 sine of 1/3 x. Find the amplitude of the period. You've already done those kind of problems, haven't we? Okay. So find the amplitude of the period, sketch the graph, and find the 5 key points, right? Like the way we've been doing so far. Now, I want you to look at question number 2. There's only 2 questions on it, by the way. Graph y equals 2 cosine or cosecant of 3x. In order for me to do this one, don't I really have to know how to do that one right there? Right? So once I do problem number 1, problem number 2 should be an easy breezy cover roll type problem to do, right? Because all I'm going to do now is do that other part. Does that make sense? Okay, so it's just 2 questions, guys. You got a whole week to get it done. You want to work together, work together. If you want to work on your own, you can work on your own. But the whole point is I'm trying to make this as straightforward for you guys as possible. Does that make sense? Good. Okay. So you can print it in, like if you want to print it out, work it out, you can print it to me next Monday. If you prefer to work it out, like I know he does it on his iPad and he's going to save it. Do you do your iPad testing too? Javier? Yeah. So if Javier say wants to do it on his iPad and just send me an electronic copy, that's fine too. Either way is good. If you want to print it out, print it in, that's good for me too. And I'll grade it and I'll have it back to you guys by Wednesday. We'll print in Monday. I should have it to you by Wednesday. All right. So anyway, just wanted to kind of give you some info on that. So let's see. Where are we? Here we go. All right. Okay, so let's take a look at this next one here. We're going to graph y equals cosecant of pi over 4. Okay, so guys, in order for me to graph this function here, what do you think we should do first? Very good. We're going to graph sine of x minus pi over 4. All right, first question. What's my amplitude? 1, right? So guys, remember, if you don't see a number in front, the number here is supposed to be 1, so amplitude is still 1. What about our period? What's the number in front of the x? 1. So it's 2 pi over 1, still 2 pi, right? Okay, so remember what we're going to do. We are now going to solve this inequality. All right, so how do we get rid of that minus pi over 4? So think about it this way. We're going to do the opposite. If we're subtracting it, we're going to add it. Perfect, guys. Okay. All right, so this is going to give me pi over 4 less than or equal to x is less than or equal to. So guys, remember, we need to add those two numbers together. So we need to get a common denominator, right? So think about this as 2 pi over 1 plus pi over 4, where 4 is going to be my common denominator. Anybody know what 8 pi over 4 plus another pi over 4 is? 9 pi over 4. So remember what we've done so far. We found the first. We found the fifth. We still got to find points 2, 3, and 4, right? Okay, so let's do that. Let's do that right here. We're going to put x minus pi over 4 equals pi over 2. X minus pi over 4 e to the pi. X minus pi over 4 equals 3 pi over 2. Okay. All right, so just like we did before, y'all, we're going to add pi over 4 on both sides. Okay, I need to get a common denominator again, so I'm going to multiply this guy by 2 and this guy by 2. So that's 2 pi over 4 plus that other pi over 4. Everybody agree to be pi over 4? Okay. So let's add a pi over 4 here, and a pi over 4 here. So again, I need to get another common denominator. So 4 pi over 4 plus another pi over 4. Anyone know? There you go. Okay. And we got to do this one last time. And multiply this guy by 2 and this guy by 2. And 7 pi over 4? Okay, perfect. All right, so let's see. Let's see, I know I'm zooming out a whole lot, guys. I just want to make my table. So let's go like this. Let's go x. So we're going to start with pi over 4. And then it looks like it's 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, right? Okay, so let me fix that real easy. And then we said 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. And on the inside, we have an x minus pi over 4. So these are just those standard values. And then we're just taking the sine of that. So the sine of x minus pi over 4. So let's see, what did we say the sine of 0 was? So what's the y value over here? 0. 1, 0, -1. There we go. Okay. So now that we have that, let's go ahead and draw this. So I'm going to sketch my picture here. Okay. We're starting at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. And we're just fluctuating between 0 and 1. So I'm going to do this one in red. 0, let's go up to 1, negative 0, 1, 0, -1, 0. So there's my picture, right? And then let me do my vertical asymptotes. Okay. And then in blue, I'll just come back and do this. What do you guys think? So far, so good? Yeah? All right. So let's try this next one here. Again, guys, so I'm going to do a few of these just to make sure that we're all good. And so here it says, let's graph y equals the secant of 2 pi x. Okay, so step number 1, let's see. We're first going to graph, let's see, y equals what? Cosine, very good, of 2 pi x. Okay, anybody know what the amplitude is here? Okay, let's find our period. So to find the period, we're going to take 2 pi, and we're going to divide it by what? 2 pi. So that's just going to give me 1. Okay. And then we're going to do this piece here. And since we want to solve for x, we're going to get rid of the 2 pi by dividing by 2 pi all the way across. So 0 less than or equal to x less than or equal to 1. Okay, so remember, this is now my first and my fifth. And so now we're going to solve each of the other ones. We're going to go 2 pi x equals pi over 2. 2 pi x equals pi. And 2 pi x equals 3 pi over 2. Right. So far, so good? Can I do what I'm saying? Yes. All right. So, guys, I want to give you all a second, and you tell me what you get for each of these. So guys, the reciprocal would be multiplying by here would be 1 over 2 pi. So those are going to cancel out. And so we'll just be left with our x right here equals, let's see, this pi and this pi are going to cancel. Everybody agree 1 over 4 for that first one? Yeah? Okay, same thing here. Over here, this pi and that pi are going to cancel. Everybody agree 1 over 2? Okay. This pi and that pi are going to cancel. 3 over, okay, and you got it. Okay. So let's make our little chart. We're going to go x. We're going to go 0, 1/4, 1/2, 3/4, 1. And then we're going to go 2 pi x, 0, pi over 2, pi, 3 pi over 2, 2 pi. And we're going to go cosine of 2 pi x. Okay. Cosine of 0? 1, good. Cosine of pi over 2? 0. Negative 1? 0 and 1. Okay. Let's do it like this. One-fourth, 1/2, 3/4, and 1. We're going between 1 and negative 1. So like this, like this, like this, and like this. They're my vertical asymptotes. And then we'll go with green. I will sketch my graph. And you got it done. Questions, anybody? What do you think? Level of 1 to 10? 10 being easy breezy cover girl, 1 being like this is super, super hard. What do you guys feel? I just go a little fast? Good. Yeah. Okay, so guys, we're gonna figure out how do I graph tangent, cotangent functions, okay? Just like the same way that we said, well, if I gave you the values 0, pi over 2, pi, 3 pi over 2, 2 pi, we can figure out what the sine and the cosine of those values are. We're going to be able to do the same thing for tangent and cotangent. We're just going to use some different values, okay? So, remember what the tangent is defined as. The tangent is defined as the sine divided by the cosine, right? So since we're dividing, that automatically tells me, you know what? We're going to have some vertical asymptotes because there are times when the cosine is equal to 0. I know that at pi over 2, the sine is 1, right? But the y value is 1, but the x value is 0. That tells me I'm going to have a vertical asymptote there, right? And so right here, we're going to have vertical asymptotes anytime we're dealing with odd multiples of pi over 2. What does that mean? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. It has to be an odd multiple of pi over 2, okay? And so it says the tangent function is an odd function. It's symmetric with respect to the origin. Each quadrant 1 point has a mirror image in quadrant 3. And the period of the tangent function is pi. So one complete period occurs between two consecutive vertical asymptotes. I'll explain what all that business means in a little bit. Okay. Same thing's going to happen for cotangent. And when you look at the pictures, what do you notice about, say, the shape of this graph here compared to that graph there? Kind of looks like it, like if you were to flip it over, right? Didn't you kind of get that same picture, except if you turned it this way? Okay, so I'm going to explain how we're going to do this here. When we're talking about the tangent function, what we're going to do, the values that we're going to use, y'all, are going to be these values right here. Okay. At negative pi over 2, tangent is undefined. At negative pi over 4, tangent is equal to -1. At 0, tangent is equal to 0. At pi over 4 is equal to 1. And at pi over 2, it's undefined. And this gives me right here the basic shape of a tangent function. Okay. So if you notice here at pi over 4, this value here is -1. At pi over 4, it's equal to +1. Since my graph is going down here, as I'm approaching negative pi over 2, I'm approaching negative infinity in the y value, meaning my y value is getting smaller and smaller and smaller in the negative direction. As we're getting closer to the pi over 2 coming this way, my y value here, is getting bigger and bigger and bigger, and that's why it's approaching that vertical asymptote. Okay. All right. The x-intercepts are going to happen at multiples of pi. So 0, pi, 2 pi, 3 pi, 4 pi, things like that. Okay. There's no maximum value, so there's no amplitude, anything like that. Okay. So what I have here, y'all, is basically like guidelines on how do I graph tangent and cotangent. So I have the basic table of values that we're going to use, say, for tangent. So here it is for tangent. And all I did, y'all, is I just copied this piece right here, and I just put it kind of like in our table form like we've been doing so far. So when x is negative pi over 2, tangent is undefined. At negative pi over 4, it's at 0. At pi over 4, it's at 1. Pi over 2 is undefined. Okay. And so what we're going to do is we're going to solve those equations. And this is for graphing y equals a tangent of dx. Okay. So what we're going to do is we're going to solve the equation dx equals each of these values here, kind of like we've been doing so far. Okay. So let's see if we can figure this out. Let's see if we can graph y equals -3 tangent of 1/2 x. Okay. So in essence, what I'm trying to do, y'all, just like we did before, we are going to solve these problems here. We're going to take 1/2 x and we're going to set it equal to these 5 values. Negative pi over 2, 1/2 x equals negative pi over 4, 1/2 x equals 0, 1/2 x equals pi over 4, and 1/2 x equals pi over 2. Okay. Now, if you remember before, when we were doing the sine and the cosine, we would normally put whatever we had in the middle, and we would do that inequality from 0 to 2 pi. We're not doing that here because we're not using 0 and we're not using 2 pi. We would use 0 and 2 pi because that was my first point and my fifth point. But now my points are going to be at these values. And that's why I'm setting each of these here equal to those values there, right? Because my x values are now a little bit different. All right. So now, first thing is we need to get rid of that 1/2. So what's the reciprocal of 1/2? G. So we're just going to multiply everything here, y'all, by 2 over 1. All the way across. So let's see, those 2's are going to cancel. That's going to mean with x equals, these twos are going to cancel. That's going to be a negative pi. These twos are going to cancel. That'll leave with an x. This 2 will reduce with that 4. What am I going to get over here? Yeah, negative pi over 2, perfect. These 2's are going to cancel. Anybody know what 0 times 2 is? There you go. Those 2's are going to cancel. This 2 and that 4 will reduce. That should just be a positive pi over 2. And then these 2's will cancel. And that should just be a positive pi. Right? All right. So what we're going to do now, y'all, is we're going to take each of these values right here. Those are going to be my original x values. That'll be a negative pi, a negative pi over 2, a 0, pi over 2, and the pi. And then notice, we already have the 1/2 x. Those are those kind of special values, right? So look at what we're doing here, y'all. We are now taking the tangent of 1/2 x. So really what I'm asking myself is, what is the tangent of these values? And that's exactly what we have in that table right there. So what's the tangent of negative pi over 2? Undefined. So I'm going to put UND. And then the next one at pi over 4? Negative 1, 0, 1, and again undefined, right? Okay, now what we're going to do is we're going to take those values that we got in that third row, and we're now going to multiply them by negative 3. What's negative 3 times something that's undefined? It's still undefined, right? Okay, what's negative 3 times a negative 1? 3. 3 times 0? Negative 3 times 1? Negative 3. And negative 3 times something that's still undefined is still? Okay. So, how am I going to do this picture? The same way. I want to show you something. I'm going to draw my graph here. Look at my x values. My x values are going between what two values? Between, what's the furthest value all the way to the left? In my top part right here. Yeah, what kind of pi though? But this one, negative pi, right? So we're going to go right here. We're going to go negative pi over 2, 0, pi over 2, and pi, right? Excuse me. Look at my y values, guys. These are my y values down here. My y values, in terms of, I know there's some undefined there, but besides the undefined, they go between what two numbers? Look at the last row. Negative 3 and positive 3, right? So we're going to go like this. 1, 2, 3. 1, 2, 3. Okay. And now we're going to go ahead. Yes, sir. Oh, you can put 3 if you want to. Yeah. Don't bother me. Okay. So look at when we're going to use 3. We're going to use 3 at what value of x? The x value, the y value will be 3 when x is what value? Negative pi over 2. So I'm going to start up right here at 3. Oops. And then at 0, we're going to be at 0. And then pi over 2, we're going to be at, come on, Ken, negative 3, right? And guys, where these undefined businesses are, those are going to be my asymptotes. Okay? And now what I'm going to do is I'm going to draw my graph. It's a little messy, but you kind of get the idea. right? The only thing that's different from this problem, excuse me, compared to the ones we were doing earlier, is the process I'm doing is still the same. It's just I'm starting off with a set of different values. I'm going from negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, right? Those are the values that they're gonna be kind of like my standard values, kind of like the way we did 0, pi over 2, 3 half pi over 4, pi, 3 half pi, 3 pi. Same sort of concept, just different values, right? All right. So I'll tell you what, guys, it's almost 3. Let's take a little break, and then we'll come back, and it looks like we got 3 more problems to do. And we'll be done with, what section is this, 4.6? So let's take a little break. It's 2:56. I don't know. Let's come back at 3:10, and then we'll finish the rest of this stuff off, okay? So I'm going to just stop recording.